Welcome everyone. I'm 𝗕ecie Fitzpatrick and I'll be your moderator today. Thank you so much for joining us here at 𝗕Comm Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are very excited to host today's event, Cisco AI Stack Masterclass, from strategy to deployment and operations. And now it's my pleasure to introduce today's instructor. 𝗷𝗂𝘀 𝗦𝘁 is an experienced networking professional and technical trainer with over 5 years in the IT training industry. He's delivered enterprise-grade, hands-on training programs for networking professionals with a strong focus on Cisco technologies, network design, and performance monitoring. 𝗷𝗂𝘀 brings a practical, real-world perspective to today's session, helping learners connect concepts with how they're applied in modern enterprise environments. Please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at 𝗕commlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. 𝗕Comm Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Data and AI practice area. 𝗕Comm Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at 𝗕commlearning.com. Enterprise technology is rapidly evolving as organizations adapt AI to improve decision-making, automate operations, and generate new business insights. As AI initiatives grow, the focus is shifting beyond models to the infrastructure, networking, and operational frameworks required to run AI reliably and at scale. Today's session will provide a practical overview of the Cisco AI Stack, explaining how AI strategy connects with AI-ready infrastructure, enterprise deployment models, and operational monitoring. The goal is to help professionals understand how AI environments are built and what skills are needed to support and manage AI across modern enterprise IT environments. Now I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handout section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic. Hey, Oshkosh, thank you so much for joining us today.
Okay. Thank you so much, Tracy. And good morning, everyone. First of all, thank you for taking the time to join the Cisco AI Masterclass. My name is Akash Nigam, and I'll be your speaker for the session. I work extensively in the enterprise networking and AI infrastructure domain, where my focus is on bridging the gap between the traditional enterprise IT architectures and modern AI driven platforms. Over the years, I've worked with organizations on enterprise network architectures, cloud and hybrid infrastructure, AI workload deployments, and large scale infrastructure design. My work sits at the interaction or the intersection of network engineering, enterprise architecture, and AI infrastructure strategies. So, in this session, we are not just going to talk about AI from a theoretical perspective. Instead, we are going to examine AI from the viewpoint of enterprise infrastructure and operational deployment. Because today, the real question that organizations are asking, it's not what is AI? The real question is how do we run AI reliably at the enterprise scale? How do we integrate AI into the existing infrastructures, security models, enterprise workflows, and the existing data ecosystems? And that's exactly where this masterclass is going to help you answer. So, whether you are an IT architect, a network engineer, a cloud architect, any technology leader, or someone who is involved in enterprise AI initiatives, this session will help you understand how AI becomes operational infrastructure, not just the experimental technology. Now, before we dive into the technical layers, let's take a quick look at what we will cover today. So, let's briefly walk through this entire structure of the session so that you should know what you have to expect. This masterclass is organized into 7 major sections, and each section builds logically on the previous one. So think of this session as a journey through the enterprise AI stack. We'll begin with introduction and context. Here we'll discuss a very important question. Why do so many AI initiatives struggle to move beyond experimentation? Many companies, they start their AI projects, but a few successfully scale them across the organization. So understanding that gap is critical here. After that, we move into enterprise AI strategy. This is where successful organizations begin. Because see, AI cannot exist in isolation. AI initiatives must align with business objectives, IT strategies, and governance framework. Next, we'll move into infrastructure and architecture. This is where my networking and infrastructure background comes into play. AI workloads, they introduce completely different infrastructure requirements compared to the traditional applications. So here, we'll talk about things like GPU clusters, high performance networking, distributed data platforms, and orchestration systems. Then we'll explore about the deployment models. Interesting one. Organizations today, they can deploy AI using several architectures. They could go for cloud AI, private AIs, hybrid AIs, or even the edge AI. And each approach has different trade-offs around control, cost, compliance, and scalability. After that, we'll discuss operations and observability. Because see, running AI models in production introduces challenges like model drift, monitoring complexity, infrastructure bottlenecks. Then we'll discuss organizational readiness and skills requirement. Why to discuss this? See, scaling AI is not just a technology challenge. It's also a people and skills challenge. And finally, we'll conclude by exploring the future trends that are shaping the enterprise AI over the next 2 to 5 years. Now that we know the exact roadmap, let's define the learning objectives for this session. Every good technical session should leave you with clear, actionable knowledge. So, by the end of this masterclass, there are 5 key capabilities you should walk away with. First, you will understand how AI initiatives align with the enterprise IT strategy. And this is very important. because AI initiatives often fail when they are treated as isolated innovation objects. In reality, AI must integrate into the existing IT architecture ecosystem, which includes infrastructure, security models, networking, data governance, and operational monitoring. The second capability is assessing the enterprise AI readiness. Not every organization is ready to scale AI immediately. Some organizations that I've seen, they struggle with poor data quality, insufficient infrastructure, skills shortage, and even the governance gap. So understanding the readiness, it will help the organizations to avoid those expensive mistakes. Third, we'll discuss about the infrastructure and the operational requirement which is needed to scale your AI. Listen it carefully. AI systems, they require massive compute resources. Distributed training infrastructure is needed, high throughput storages are needed, and even a low latency network. And if infrastructure is not designed correctly, AI workloads quickly become inefficient and expensive. Fourth would be where we'll be doing a comparison between different deployment models. We'll analyze what a cloud AI platform is, what are the different private AI environments, hybrid architectures, and the edge AI deployments. Every model will be having its own advantages depending on the data sensitivity, compliance requirements, and performance needs. Finally, we'll try to identify the roles and the skill sets which are required to support enterprise AI programs. Because see, AI success, it requires collaboration across multiple disciplines. So, with that foundation established, let's talk about a very interesting reality that we see across the industries today. Organizations everywhere want AI, but executing AI successfully is far more complicated than many people expect. Across industries today, AI ambition is extremely high. Executives, they talk about AI constantly. Boards, they ask about AI strategy. Investors, they try to expect the AI driven innovation. But despite all of this excitement, execution often falls short. Why does this happen? There are four major reasons to it. The first challenge is the fragmented data and unclear ownership. Most of the organizations, they have data which is spread across multiple systems. It would be around the databases or around the SaaS platforms. It could be any legacy application or any internal data warehouses. So all these systems, they often operate in silos. So without unified data governance, AI systems, they will struggle to access consistent data inputs. Now, talking about the second challenge. Second challenge is AI pilots that never reach productions. Many organizations, they successfully build proof of concept models, but when they attempt to deploy them at scale, problems appear. Problems could be like they might face integration being very difficult, infrastructure becomes insufficient, or even the operational monitoring becomes complex. So pilots, they remain stuck in the experimentational environments. Third, third issue is the skills gap and even the immature governance framework. AI, it requires expertise across multiple domains. It could be data engineering, machine learning, infrastructure engineering, cybersecurity, and compliance governance. And most organizations, they're still building these capabilities. Finally, there are security and integration risks. See, AI systems, they often connect to critical enterprise systems. For example, it could be your ERP systems, it could be your CRM platforms, or any operational database. So these things, this dramatically increases the attack surface, which means security has to be considered from the beginning only, not after deployment. So now the question becomes, how do successful organizations overcome these challenges? And the answer to this becomes, or it starts with structure. See, there is a misconception in many organizations. People, they often think infrastructure slows the innovation, but in reality, structure or your basically the exact structure, it will accelerate the innovation. Organizations who are adopting AI, Without structure, usually they will run into serious problems. One major issue is the AI's technical debt. Different teams adopt different tools, different models, different infrastructure stacks. Eventually, the organization ends up with multiple disconnected AI environments. Another challenge is the misalignment that will be between the AI teams and the business teams. Any AI engineer may build sophisticated models, right? But those models might not align with the measurable business outcomes. And this is something which makes it difficult for leadership to justify the continued investments. And the third problem, sorry, and the third problem is fragmented technology investments. Organizations, they buy multiple AI platforms, but with a unified architecture, this creates friction across the entire system. Any organization, it might need, if it wants to succeed, or any organization that has succeeded with AI, they definitely do something different. What they do, they build a structured AI lifecycle framework, and that framework includes governance models, reusable infrastructure, shared data platforms, and standardized security policies. And that is a structured approach which will allow AI to scale consistently across the organizations. Now, this leads us to an interesting reflection question, which is, where does your organization currently sits on the AI maturity curve? Everyone, most organizations today fall into one of the three maturity stages. The first stage is exploring. Organizations in this phase, they are still evaluating AI opportunities. They are researching use cases, they are running experiments, understanding what AI could potentially do for their businesses. And at this stage, the focus is learning and discovery. Then comes the second stage, which is piloting. In this phase, organizations begin building proof of concept models. For example, predictive analytics model or recommendation systems, even customer support automation. These pilots, they demonstrate value, but they still remain limited in scope. Then comes the third stage, which is deploying, scaling, and optimizing. Here, your AI becomes the part of the core enterprise operations. Models, they keep on running continuously. They integrate with business systems. They influence decisions in real time. And organization actively manages AI infrastructure. Now, the key point here is that each stage, each one of these, each stage requires different strategies and investments. And understand, when you try to understand your stage, that is when it will help you to determine your next step. Now, to determine the readiness of scaling your AI, we need to evaluate several foundational dimensions. Scaling AI successfully requires readiness across several key dimensions. So onto the screen, you are looking at the five most important ones. The first one definitely is the data. Data is the foundation of every AI system. If your data is incomplete, inconsistent, poorly governed, then AI outcomes will also be unreliable. Second dimension is infrastructure. AI workloads, they demand specialized infrastructure, including your GPU clusters, distributed storages, and even high bandwidth networking. So, without sufficient infrastructures, models cannot scale effectively. The third dimension, that is talent. Organizations, they need the right combination of skills. ML engineers, data engineers, infrastructure architectures, and even domain experts. The fourth dimension is governance. Governance ensure AI is used responsibly and safely. It will include compliance policies, ethical AI frameworks, models accountability structures. And then comes the final dimension, that is strategy. AI investments, they must connect directly to business outcomes. So without strategy, AI becomes experimentation rather than transformation. Now, once we are done with this, let's go deeper into the concept of strategic alignment. Strategic alignment is something where any or most of the AI initiatives either succeed or they fail. See, AI projects, they should never begin with technology. They should begin with the business problems. For example, I want to improve customer experience, or my need is to reduce the operational cost, or I just want to optimize the supply chains. So once you have defined your problem clearly, organization can determine how AI can help to solve it. And another key concept here would be business and IT alignment. Look here, see, successful AI initiatives, they involve collaboration between IT infrastructure teams, data engineering teams, security teams, and even the business leadership. Because AI systems will impact the entire organization. And another important practice is use case prioritization. Organizations, they should evaluate AI projects based on potential impact, technical feasibility. So starting with high value achievable use cases, it will help build momentum and stakeholder support. Now, let's examine a practical framework that the organizations can use to structure their AI strategies. The framework consists of four layers. The first one here is vision. This layer defines the organization's AI ambition. It answers questions like what problem should AI solve? Or how will AI create competitive advantage? Then comes the second layer. Second layer is strategy. Here, organizations define use cases, governance structure, and implementation roadmaps. Then comes the third layer, which is about foundation. This layer includes infrastructure and data platforms that will support AI systems. So without this foundation, AI initiatives cannot scale. And then comes the final layer, which is the execution. This will include your model's deployment, integration with enterprise systems, operational monitoring. And each layer, it depends on the previous one. And weakness in any layer, it can limit the success of the entire AI program. Now, before we move into the infrastructure section, let's quickly summarize the key takeaways from the strategy discussion. So first was the AI adoption, which is structurally complex. Organizations, they must approach it with deliberate planning. Second would be the readiness assessment, which is done across multiple dimensions that will help you identify gaps even before scaling. And third, alignment between the AI initiatives, IT strategies, and business outcomes. That is very essential. Now, I just want you all, I just want to ask something to you all, which will give you a quick sort of a reflection question. What is currently the biggest strategic challenge in your organization's AI journey? Think about it. Is it data quality? Is it the stakeholders alignment? It could be infrastructure limitation or any skill shortage. Even governance concerns could be there. So just take a moment to think about that, because identifying the bottleneck is often the first step towards solving it. And now that we have established the strategic foundation, we are going to move into the technical infrastructure layer of the AI stack. And this is where things start getting really interesting, everyone. Now, let's start the exploration for the infrastructure components that make enterprise scale of AI possible. So the next logical step after discussing about strategy and readiness is to examine the technical foundation which are required to run AI workloads at enterprise scale. See, because strategy, it alone cannot run AI. Infrastructure can. Whenever organizations begin scaling AI, they quickly discover that traditional IT infrastructure is not sufficient. AI workloads, they have completely different operational characteristics which as compared to the traditional enterprise applications. For example, you can take an ERP system or CRM system, which typically possess the structured transactions. But AI workloads, they involve massive data sets and continuous model inference. So all this, it requires a specialized infrastructure stack, which is composed of several key layers. And on this slide, I'm going to walk you through those particular layers one by one. The first layer is compute. AI training workloads, they require accelerated computing resources, particularly the GPU clusters. GPUs, they are specifically designed for parallel processing operations, which makes them ideal for matrix multiplication, which is used in machine learning. Now, in enterprise environments, these GPU clusters often consist of your NVIDIA GPUs, AI accelerators, and specialized compute nodes. So working together to process extremely large data sets, they all will be like reliable for you. Now, one important point that you should remember, and which is AI workloads, they are highly compute intensive. So capacity planning, it becomes very important. Organizations, they have to redesign infrastructure capable of handling both training workloads and real-time inference workloads. Now comes the second layer, which is the storage. AI systems, they require storage platforms which are capable of handling massive data volumes and extremely high throughput. Traditional enterprise storage, it often struggles with this requirement. So now, modern AI environments, they will rely on your distributed storage system, object storage systems, and even high performance parallel file systems. So these files or these particular systems, they allow large data sets to be accessed by multiple compute nodes simultaneously. So without this capability, training jobs slowly and gradually they slow down dramatically, I should say. And then comes the networking layer. This is especially important for those with networking backgrounds. This is high performance networking. This is the third layer. AI clusters, they require extremely low latency and high bandwidth network fabrics. During distributed training, thousands of GPUs may need to exchange data continuously. So if networking becomes a bottleneck, the entire AI workload slows down. And this means organizations must design high performance network fabrics capable of supporting large scale distributed computing. And then comes the data platform. This is the fourth layer. This place includes systems like data lakes, lakehouses, or featured stores. These platforms, they prepare an organized data for model training and inference also. Because remember, AI systems, they are only as good as the data they consume. And finally, we have the orchestration platform. These platforms manage how workloads are scheduled and executed across the infrastructures. We have heard about tools like Kubernetes or container orchestration systems, or even the AI workload schedulers. These are those particular resources which will help you to ensure compute resources are used efficiently. So the key takeaway from this slide is very simple, everyone. Enterprise AI is not just about models. It is about the entire infrastructure ecosystem that supports those models. And if any of these layers is weak, the entire AI system becomes unstable. Now that we have understood about the infrastructure layer, let's talk about how these systems should actually be designed. Because building AI infrastructure, it requires careful architectural planning. So when you are designing the enterprise AI systems, organizations have to follow several key architectural principles. And these principles ensure that your AI system remains scalable, resilient, secure, and manageable. So let's examine the most important ones out of it. Everyone, the very first principle, no doubt, it would be scalability. AI workloads, they grow rapidly. Data volume increases rapidly. Models, they become larger in size, and user demand, it also expands. So infrastructure has to be designed to scale from the very beginning. If scalability is not considered early, organizations eventually need to redesign the entire architecture. And that's a sad part. Now, the second principle is modularity. Modern AI systems, they should be composed of independent components. For example, your data ingestion systems, model training pipelines, inference services, and even the monitoring systems. Because see, if these components which I just named, if they are tightly coupled, updating one component can break the entire system. But modular architectures, they allow teams to upgrade or replace the components independently. And that leads to the third principle, which is resiliency. See, AI systems, they must remain operational even when the components fail. So infrastructure, they should include redundancy, failover mechanisms, and distributed workloads, because downtime in AI system, it can disrupt business operations, and neither me nor any of you would like to hear that. Another critical principle is security by design. Security should not be added later. No. Instead, it has to be embedded into the architecture from the very beginning, where it will include your identity access controls, encryptions, secure APIs, and even the audit logging. And finally, the final piece or the final principle is observability. Enterprise AI systems, they must provide visibility into the model behavior, infrastructure performance, and data flows. Because without observability, organizations cannot diagnose problems quickly. So now that we have understood the architectural principles, let's examine something that is particularly important in AI infrastructure, and that is compute and networking performance. So this slide highlights a very important reality in AI systems. Compute and networks or the networking, they are very massively, like, they're deeply interconnected. Okay, so let's start with compute first of all. All the AI training workloads, they require massive processing power. So large models, which are especially the modern deep learning models, they require thousands of parallel operations. And that is why organizations rely heavily on GPU clusters and specialized accelerators. CPUs, they alone cannot handle this workload efficiently. Now, however, compute alone is not enough. Dis- that because during distributed training, GPUs constantly exchange data. So if the network cannot move this data quickly enough, GPUs are spending time waiting instead of computing. And this is something which will create your networking's bottleneck. And if that bottleneck is created, it means expensive GPU resource remain underutilized. Now, one more thing is written here, the RDMA, which is your, so let me just explain it in an easier way. This is one of the important technology in high performance AI clusters. It's called as remote direct memory access. So I'll call it as RDMA throughout the session. RDMA, it allows data to move between servers without even involving the CPU. So in this will somehow reduce your latency and improve throughput significantly. And if I talk about large AI clusters, technologies like RDMA will help maintain the efficient distributed training performance. Another important challenge is resource scheduling. So multiple AI workloads, they may run on shared infrastructures. So if resources are not isolated correctly, workloads compete for compute capacity, and this causes unpredictable performance. So organizations, they have to implement advanced scheduling and isolation mechanism. Finally, we talk about training versus inference. See, it's important to understand that difference between the training workloads and inference workloads. Training is something which requires massive compute resources, and inference is something that requires low latency and high throughput. So many organizations, they mistakenly run inference workload on the training infrastructure, but optimizing the infrastructure for inference, it can significantly reduce the cost. Now that we have explored compute and networking, let's shift our attention to another foundational layer, and that layer is data architecture. In many ways, data architecture is one of the most critical component of enterprise AI. We all can build powerful models, But if the data feeding for those models is unreliable, the result will also be unreliable. So let's explore several important concepts here. The first would be the data quality and lineage. Organizations, they must know where the data is coming from, how is it transformed, and how is it used in the models. Because without lineage tracking, it becomes difficult to trust the model's output. Next comes the lakehouse architecture. Many organizations now use this particular architecture, and lakehouse combines the advantages of data lakes and data warehouses. That is how it allows the structured and unstructured data to coexist within a unified platform. And this is something which will simplify the AI data pipelines. Now, another important concept is the feature store. This is something which will maintain reusable features which are used in the machine learning models. So instead of rebuilding features repeatedly, teams they can access standardized feature libraries. And that is how they can improve their efficiency and even the consistency for them. Finally, the modern AI systems increasingly rely on the real-time pipelines or real-time data pipelines, I should say. See, batch processing alone is not often sufficient because applications like fraud detection or recommendation systems, they require real-time inference. And for that purpose, it requires streaming the data architectures. So far, we have discussed infrastructure, architecture, compute, networking, and data. But there is another extremely important dimension that we should consider. And that dimension is nothing but security and compliance. AI systems significantly expand the attack surface of the enterprise environments. Why? Because AI systems introduce new components like training datasets, model pipelines, inference APIs, and data processing workflows. So each of these components, they become a potential security target. AI has introduced unique attack vectors. For example, model poisoning. Model poisoning is something where attacker manipulates training data to influence model behavior. Then prompt injection. Prompt injection is where attacker crafts input designs so that it can manipulate the model outputs. And then comes the data exfiltration. See, sensitive training data, it may be extracted through the model interaction. So this risk requires organization to implement AI specific security controls. Another critical area is identity and access management. Access policies, they must apply not only to the users, but also to the AI models, APIs, and your data pipelines that you're using. So zero trust principle, it should govern access across the entire AI lifecycle. Then comes data protection. See, sensitive data, it must be protected using technologies like encryption, access control, or even the data masking technologies or the techniques. So organizations, they have to be ensured that data privacy should be maintained throughout the entire AI pipeline. And finally, AI systems, they must comply with regulatory frameworks such as GDPR, HIPAA, or SOC2. So organizations, they must map all these compliance requirements directly into the AI infrastructure. So now we have explored the major infrastructure layers which are required for the enterprise AI. And in the next section, we will step back and summarize what we have learned before moving into the deployment models and the integration strategies. That's the next flow. Now, a quick review. We have talked about infrastructure, networking, data platforms, compute clusters, and security considerations. So, and at this point, some of you might be thinking that, oh my God, this sounds so complex. Is all of this really necessary just to run the AI? So everyone, the short answer is yes. If you want AI to scale reliably in enterprise environments, then the answer is yes. Now, let's pause for a moment and summarize the entire key idea from the infrastructure and the architecture section. Because once you understand the bigger picture, It is just as important as understanding the individual technologies. So the first major takeaway is enterprise AI infrastructure is a multi-layer system. It will include compute resources, storage platforms, networking fabrics, data architectures, orchestration systems. And each of those layers, they must work together seamlessly. If let's suppose if any of your layer becomes a bottleneck, your entire system might suffer. For example, if networking bandwidth is insufficient, distributing training slows down. If your storage throughput is insufficient, training pipeline fails or it stalls. Let's say if your orchestration is poorly designed, compute resources may remain unutilized, underutilized, we say, right? I have discussed about it a few slides back. So AI infrastructure, it must be designed holistically, not component by component. And the second key takeaway, it was about the architectural principles that must be established early. Principles like scalability, modularity, resiliency, and security by design. So if these principles are ignored early on, organizations often find themselves rebuilding their AI platforms later. And rebuilding infrastructure, trust me, it is very expensive. Another major key takeaway is data architect. Data architecture is a critical enabler of AI. Organizations, they they sometimes invest heavily in compute resources, but they ignore the data governance. So see, even the most powerful models, they cannot compensate for poor data quality. Clean, accessible, well-governed data, that is the foundation of the reliable AI. And finally, security and compliance. See, security cannot be an afterthought. Security and compliance, they must be embedded across every layer. I'm repeating again, they have to be embedded at every single layer. Many organizations, they attempt to add security controls later, but I'm sharing my experience. AI pipelines, they process large volume of sensitive data. And that means security has to be integrated from the very beginning only. Now, I'd like everyone to think about your own organizations for a moment. If you were asked today, is your infrastructure truly ready for large AI scale workloads? What would your answer be? Would it be absolutely yes, partially ready, or not ready yet? This reflection is very important because infrastructure readiness often determines whether AI initiatives can succeed or stall. Now that we have built a strong understanding of infrastructure, let's move into the next major topic. And that topic is deployment models. Because once your infrastructure is understood, the next question any organization may ask is, where should I actually run this AI? So let's answer that question altogether. Whenever organizations deploy AI systems, they typically choose between four major deployment approaches, and each approach involves trade-offs. So let's explore them one by one. First, speed of deployment. Cloud providers. See, cloud providers, they offer ready-to-use AI infrastructure. And organizations, they can launch AI experiments quickly without even building the physical infrastructure. Second, elastic scalability. If I talk about the cloud environments, they allow organizations to scale compute resources dynamically. And this is specially used for AI training workloads, which can require large bursts of compute power. So, however, cloud deployment also introduces challenges. What are those challenges? Challenges like data residency requirements or your regulatory restrictions. Even in cloud, there is a concern about sensitive data leaving the organizational boundaries. So this was your first model, which is a cloud-based AI deployment. Second, the second model is your private AI infrastructure, which is deployed on premises. So in this model, all AI workload runs inside the organization's own data center. And this approach, this will provide you the maximum control over the data and infrastructure. And that is what makes it attractive for the industries like the financial services, healthcare industries, government industries, and even the defense industries. However, the trade-off here is cost, because building and maintaining a private AI infrastructure, it definitely will require significant investment in your hardwares, in your facilities, and in the operational teams. And that brings us to the third model. Third model is hybrid AI infrastructure. So this model, I find it interesting. See, this model combines on-premise infrastructure with the cloud resources. So that means an addition of both of this results into the hybrid deployment. For example, your sensitive data, it may remain inside the enterprise data center, whereas your large training workload, it may run in the cloud environments. So hybrid models, they offer a balance between flexibility, scalability, and compliance, but they also introduce integration complexity. So organizations, they should manage security, networking, and data synchronization across all the environments. And comes the final stage or the final model, which is the edge AI. Everyone, in edge deployments, AI inference occurs close to where data is generated. For example, your manufacturing equipments, autonomous vehicles, IoT devices. So this approach, it minimizes latency and reduces the bandwidth usage. However, edge environments, they often have a limited compute capacity. So models, they have to be optimized very carefully. Now, some of you may already be thinking which deployment model is best for our organization. So let me answer it here itself. It completely depends. There's no one universal solution. Deployment choices, they have to be considered on the basis of data sensitivity, compliance requirements, latency constraints, and even the infrastructure capabilities. And that brings us to a deployment model that is becoming increasingly popular in regulated industries, the private AI environments. These are the environments which are becoming increasingly important in enterprise environments where data control is critical. In a private AI environment, all the components of AI pipeline, they operate inside the enterprise control infrastructure, which includes training dataset, model training, inference pipelines, model outputs. That means nothing leaves the organization's infrastructure boundary. Now, the question is, why would organizations even choose private AI? See, private AI is especially important in industries where regulatory requirements are restricted. For example, financial institutions, they must protect sensitive transactional data. Healthcare providers, they must comply with medical data privacy regulations. Or even government organizations, they must ensure national data sovereignty. So in these environments, sending sensitive data to public cloud environments, it may not be acceptable. So the question is, what could be the advantages? The biggest advantage of private AI is control. Organizations, they maintain full visibility and control over your data access, over the model's behavior, and infrastructure security. So this allows organizations to maintain detailed audit trials, which is very essential for compliance frameworks. Now, however, private AI also introduces some challenges, and you all should agree to it. The biggest challenge would be scalability. Cloud environments, they offer elastic compute resources, but private environments, they require organizations to plan the infrastructure capacity, and that has to be done ahead of time. So understand, if anyone underestimates the capacity, it can stall the entire workload. And overestimating the capacity, that can even waste the capital investment. So a question that I often ask organizations is this: is data control more important than infrastructure flexibility? So for some industries, the answer is absolutely yes. But for others, hybrid approaches provide a better balance. So if private AI provides control and cloud provides flexibility, is it possible to combine both advantages? Yes, and that's exactly what hybrid AI architecture attempts to achieve. All right, let's take a quick 5 minutes break and then I'll start on the remaining topics after the break.
We are now going to take a 5-minute break, but before we do that, we are going to launch a quick poll that we want to invite you to participate in. Doing so helps us know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register.
Welcome back, everyone. Let's continue from where we left off. Now, hybrid AI architecture, they combine on-premise infrastructure with cloud capabilities. And this model has become increasingly popular because it allows organizations to balance several competing priorities. So let's examine how hybrid environments typically operate. One important concept here is data gravity. Yeah, data gravity, it refers to the tendency of your large data sets to remain where they already exist. So if you move large data sets across the environment, it will be very expensive and inefficient. So in hybrid environments, organizations often keep sensitive data inside local infrastructure. Next is the cloud burst training. However, training large AI models, it requires enormous compute resources. So rather than purchasing expensive infrastructure for occasional training workloads, organizations often use cloud burst training. What does it mean? It means training workloads temporarily run in cloud environments where elastic GPU clusters are available. And once your training completes, the resulting model may be deployed back into the enterprise environments. A smart move, right? Now, in many hybrid architectures, model inference occurs on premise. And that is something which ensures data or your sensitive data, it never leaves the organization. That is how it reduces the latency for internal applications. Of course, one more thing. Hybrid environments, they require strong integration layers. So organizations, they must implement systems that provide unified monitoring, consistent security policies, and cross environment compliance. So without these integration mechanisms, hybrid architectures, they become very difficult to manage. Okay, at this point, some of you listeners may be thinking, does hybrid architecture introduce complexity? So the answer is yes, it absolutely does. But when implemented correctly, hybrid models, they provide the best balance between flexibility, control, and scalability. So now that we have understood about where AI systems can run, the next important question becomes, how do we integrate AI into the systems that organizations already use? So one of the biggest mistake organizations make is treating AI as a standalone technology platform. But let me make it very clear. AI only creates value when it becomes embedded within existing business systems. So let's think about a very simple example. Um, Suppose you have an AI model and it can predict your customer churn. So if that prediction never reaches to the CRM systems, organizations cannot act on it, right? If it never reaches you, you cannot act on it. So integration is essential here. So first integration layer, it always involves the ERP and the CRMs. These systems, they provide business context for AI models. For example, AI can have the customer data, transaction histories, and operational matrices. So AI model use all these informations to generate insights that will be directly influencing the business decisions. Second integration layer involves the API gateways. APIs manage how applications will interact with the AI models. For example, any mobile application, how will that interact? Any web platform's interaction with the AI model, or any enterprise application. So these applications may call AI model through the APIs so that they can retrieve predictions. And third integration layer, it involves identity and directory services. See, access to AI systems definitely needs to be controlled, and that will be done using the enterprise identity framework. This ensures only authorized users and systems can interact with the AI models, not everyone. Another integration layer connects AI system with IT service management tools, the ITSM. And this will allow the organization to track any incident happened. It will help the organizations to manage the service workflows, and even it will allow the organizations to respond to the operational issues. Finally, AI systems often integrate with the event-driven architecture. In these systems, AI models respond to the real-time events. For example, any fraud detection system, predictive maintenance systems, or even the supply chain optimization systems. So these systems, they will trigger the automated response based on the AI systems. So here is a question I want you to consider. If your organization deployed a powerful AI model today, would your existing systems actually be able to consume and act on its predictions? Why I'm asking this? Because see, integration, it's not just modeling. It is what ultimately creates business values. So far, we have explored strategy, infrastructure, architecture, deployment models, and enterprise integration. Now, in the next section, we'll shift our focus towards operationalizing the AI systems, which means we'll be talking about monitoring, observability, and operational best practices. So now that we've discussed how AI systems integrate with enterprise platforms, let's take a moment to step back and recap the deployment models we just explored. Because this is an important decision point for every organization who is adopting the AI. So whenever organizations move from experimentation to real production AI environments, one of the first architectural questions they face is, where should AI actually run? And as we discussed, there are four primary deployment models. Let's briefly just revisit them again. The four models were, first was the cloud deployment, which is often the fastest way for any organization to begin experimenting with AI. Here, it will allow organization to move quickly without investing heavily in the hardwares. But cloud deployments, they can introduce concerns around data privacy, regulatory requirements, and vendor lock-in. So while cloud offers speed and flexibility, it may not always be the right choice for sensitive workloads. Second option was the private AI infrastructure. In this model, organizations create and operate their own AI environments inside their own data centers. Yes, you can have full control over data access, model governance, and security policies. But private AI environments are often preferred by industries with strict compliance requirements. Whereas this particular approach of private AI, it requires significant capital investment. So organizations, they have to provision GPU clusters, high performance storage, specialized networking infrastructures. Then we discussed about the third, which was the hybrid AI architecture. So hybrid architecture allows organizations to balance scalability, compliance, and cost efficiency. But they also introduced additional operational complexity. Finally, we have the edge AI. So edge AI pushes inference workloads closer to where data is generated. And this approach is particularly used in environments such as manufacturing plants, smart cities, autonomous vehicles, and IoT environments. So edge deployments, they definitely reduce latency and minimize bandwidth usage. However, they also require careful optimization because edge devices, they might typically have limited compute capacity. Now, here's something I want you all to think about. If your organization were deploying AI today, which model would you use? Would it be cloud, private, hybrid, or the edge? Because the answer often depends on data sensitivity, compliance requirements, and operational constraints. Now, as we have explored deployment models, the next step is to think about something equally important, and that is operational visibility. Because deploying AI is the only beginning. Monitoring AI system is very different from monitoring the traditional applications. And this is something many organizations discover only after deploying AI into production. In traditional IT systems, monitoring usually focuses on infrastructure matrices. For example, CPU usage, memory utilization, network throughput, server availability. But AI systems can introduce a new dimension to it. In AI environments, you must monitor three separate layers simultaneously. And that's what I'm breaking down here. Layer 1 is your infrastructure layer. This includes traditional matrices such as GPU utilization, CPU usage, memory consumption, network latency. And these matrices, they ensure that infrastructure resources are functioning correctly. Second layer involves data monitoring. So AI models, they depend heavily on quality and characteristics of your incoming data. So if the data distribution changes over time, models accuracy may degrade. And that is a phenomena which is called as data drift. So organizations, they must monitor incoming data streams so that they can detect such changes early. And third layer is models performance monitoring. Even when infrastructure and data pipelines appear healthy, models themselves may degrade. For example, prediction accuracy may decline, confidence scores may change, output patterns may drift from the expected behavior. So, monitoring tools, they must track these matrices continuously. Another important aspect of monitoring is the alerting system. Alerting mechanism, they must distinguish between two different types of failure: infrastructure failures and models degradation. Because the response procedures for these issues, they are completely different. Infrastructure failure, if I talk, so they may require infrastructure teams. Whereas model degradation, they may require the ML teams or the ML engineers. So at this point, most of you must be thinking, do we really need this level of monitoring for AI systems? So answer is yes, because AI models can silently degrade without triggering traditional monitoring alerts. And that makes AI observability a critical operational capability. Once monitoring systems are in place, the next question becomes, how do we maintain AI systems over time? And that brings us to operational best practices for AI at scale. Let's explore several operational best practices that help organizations maintain reliable AI systems. First is versioning and rollback. So AI models, they should be treated as long-lived production assets. That means we have to maintain version history, performance benchmarks, and even the deployment records. Whenever a model is updated, organizations, they should retain previous versions, and that enables rapid rollback even if the problem occurs. Automated retraining pipelines. This is an important practice. Models, they should not be retrained on fixed schedules. Instead, retraining should occur whenever the performance matrices drop below the defined thresholds. And this will ensure that models adapt to change in the real world data. Now, controlled deployments. Whenever you are deploying new models, organizations, they should avoid the immediate full deployment. Instead, you should use strategies like blue-green deployment or canary deployments. These strategies, they allow organizations to gradually introduce model updates. And if the problem appears, the deployment can be halted quickly. Another important consideration is AI-specific incident response planning. Traditional incident responses, the procedures focuses on infrastructure outages, but AI system, they introduce unique issues. For example, hallucinations of the AI, biased predictions from the AIs, or even the unexpected model behavior that we must all have faced. So organizations, they should deploy playbooks which are specifically designed for AI related incidents. And finally, every model should have documentation, often referred to as a model card. These documents, they describe training data sources, performance matrices, and even the known limitations. So this documentation, it provides transparency and governance also. And if you think about it, managing AI systems is actually very similar to managing the software systems, but with one very important difference. AI systems, they continue to evolve even after deployment, which means operational management, it becomes an ongoing process. And speaking of governance, there is another critical component of enterprise AI that we must discuss: the AI governance and lifecycle management. Governance is one of the most overlooked yet most important aspect of the enterprise AI, because without governance framework, AI systems can introduce serious risks like biased decisions, regulatory violations, or even the security vulnerabilities. So government governance systems, they must be embedded across the entire AI life cycle. The very first principle is a clear ownership and accountability. Without clear ownership, accountability becomes fragmented. So AI systems, they must have defined stakeholders which are responsible for model deployment, deployment approval, and operational monitoring. Now, second is the model lifecycle management. AI model, it passes through several lifecycle stages, and those stages, they start with development, then a validation, then approval, then comes deployment, then monitoring, and lastly the retirement. So each stage, it must have defined procedures and decision points. Okay, another critical governance function is bias detection. AI systems trained on historical data may unintentionally reinforce existing biases. So organizations, they must evaluate models for fairness even before deployments. And in some industries, AI decisions must be explainable. For example, credit approval decisions, or hiring recommendations, or even the medical diagnosis. So these systems, they must provide interpretable reasoning behind the predictions. And finally, organizations, they should maintain a central model registry. A model registry is something that tracks model version, performance matrices, access control, and deployment history. So this registry, it becomes the single source of truth for AI systems. At this point, I want to ask something to you all. If someone asked your organization today, which AI models are currently running in production, would your team be able to answer that immediately? Because many organizations cannot. And that's exactly where governance framework are necessary. Now that we have discussed monitoring, operation, and governance, let's summarize the key lessons from this operational section. Here is a quick recap of the key principles of AI operation and observability. And there are three major ideas that one should remember. First, AI system must be monitored across multiple layers simultaneously, because only by monitoring all the three layers, any organization can maintain reliable AI systems. Second, second principle is the automate operations. That means automation. We generate large amount of operational data in the AI environments. So manual monitoring, it simply becomes impossible to scale. So automation, it will enable the organizations to detect issues early and respond quickly. And the third principle would be the life cycle governance, because AI systems, they evolve over time. So without governance mechanism, technical debt and compliance risks accumulate silently. Every organization, it should manage AI systems across the entire life cycle. So, so far we have explored strategy, infrastructure, deployment models, integration, operations, and governance. Now, there's one more dimension that we must discuss before we conclude, and that dimension is people and skills. Because ultimately, technology alone does not make AI successful. People do. Now, we need to talk about something which is equally important: the people who make AI work. Because AI's transformation is not just a technology challenge, it is also an organizational capability challenge. To successfully build and operate enterprise AI systems, organizations must need multiple specialized roles working all together. First of all, we have AI and ML engineers. These professionals are responsible for developing the machine learning models, building the training pipelines, and optimizing inference performance. And they will translate your data science research into production ready models. Next, we have data engineers. These professionals, they create and maintain the data infrastructure which is required for AI. So they will design systems that handle data ingestion, data transformation, data pipelines, and even the feature engineering. So without data engineers, AI models simply don't have reliable data to work with. Another critical role I feel is platform engineers. Platform engineers are those who design the underlying infrastructure that supports the AI workloads. And this includes compute clusters, networking fabrics, container orchestration systems. So they will ensure AI workloads run efficiently across infrastructures. But yes, we also need AI governance leaders. How can we forget that? Their role is to ensure AI systems comply with organizational policies and regulatory frameworks. So these are the people who oversee compliance, model accountability, ethical AI guidelines. Another important role is AI product owner. This role ensures AI initiatives align with business objectives. So they'll be responsible to bridge the gap between technical teams and business stakeholders. And finally, we have the security engineers. They'll protect your AI systems from varied threats such as model manipulation, data breaches, or API vulnerabilities. So one interesting thing many organizations discover is this, that AI success rarely depends on one expert. Instead, it depends on the cross-functional collaboration between these multiple team members. So once the right roles are defined, the next question becomes, how do organizations build these necessary skills across their workforce? So enterprise AI adoption requires continuous skill development across multiple teams. And most organizations approach this through these three phases of skill development: foundational, specialization, and applied. First phase of focus is completely on foundational knowledge. Enterprises, they begin learning. They learn Python programming, data structures, machine learning fundamentals. Architects, they begin studying AI reference architectures. Security teams, security team begin by understanding the AI threat landscape. And IT leaders, they begin exploring the AI strategy concepts. And this entire phase that we have discussed, it creates the organizational awareness and baseline capabilities. In the second phase, professionals begin specializing. So engineers, they start learning the ML framework and experiment tracking along with ML ops pipelines. Architects, they begin designing the AI infrastructure architectures. Security teams develop the AI specific threat models. So this stage ultimately creates the technical depth in the environment. And then the final phase that focuses on the applied deployment. Teams, they begin running real production AI workloads. Engineers, they design distributed training pipelines. Architectures or the architects, they design hybrid AI environments. Security teams, they implement data protection frameworks. And at this stage, AI becomes a core operational capability. Now, let's take a moment to evaluate organizational readiness in a structured way. So here in this slide, I tried to explain a simple but very powerful concept, a readiness scorecard. And this is for enterprise AI adoption. Organizations, they should evaluate themselves across 5 dimensions here. The first dimension is data, the data one. Organizations, they should ask themselves, is our data accessible? Is it high quality? Is it properly governed? So because without strong data pipeline, AI initiatives cannot scale. Second is infrastructure readiness. Organizations, they must ensure infrastructure can support large scale computes, the workloads for it, high throughput storages, and even the low latency networks. And the third dimension would be the talent readiness. Do we have the right mix of professionals? ML engineers, data engineers, infrastructure architectures. Fourth is governance readiness. Are the policies defined for AI lifecycle management, model accountability, or compliance frameworks? And finally, the organizations must assess strategic alignment. Are the AI initiatives aligned with business priorities or not? So, if you were to score your organization from 1 to 5 across these dimensions, what would the results look like? Many organizations, they discover gaps in at least one of these three areas, these five areas, sorry. And those gaps, they often explain why AI initiatives struggle to scale. So now that we have explored readiness and skills, let's look ahead to the future. The AI landscape is evolving extremely quickly. Over to the next 2 to 5 years, several trends will reshape how enterprise deploy AI. So let's take a look at the few key trends. Sovereign AI. First, we are seeing the rise of the sovereign AI architectures. Governments around the world are introducing regulations that require data to remain within the national boundaries. This means enterprises must design AI infrastructure around the data residency requirements. Domain specific models. Second, organizations are moving toward the domain specific foundational models. Instead of relying on generic AI models, enterprises are training models on their own proprietary data sets. And that creates the competitive advantages unique to their specific industries. Third, the AI agents. This is the emerging trend of AI agents operating autonomously in the enterprise workflows. These autonomous agents or these AI agents, they can analyze information, they can make decisions, and even they can trigger automated actions. So we are already beginning to see these systems appear in the enterprise operations, don't we? Sorry. Another important consideration is sustainability. AI workloads, they consume significant energy. I agree. So organizations, they're beginning to factor energy consumption into the infrastructure design. And finally, the AI regulation. Here, we are seeing the emergence of formal AI regulations. For example, frameworks like EU AI Act, they are introducing governance requirements for AI systems. Organizations, they must prepare for a future where AI governance becomes legally enforced rather than optional. And with that, we reach the final section of this masterclass. At this point, we have covered the emergence, we have covered all the different ranges of the topic. We discussed AI strategy, infrastructure architecture, deployment models, integration approaches, operational best practices, governance framework, skills deployment, the development of those skills, and even the future trends. So now, I'd like to open the floor for questions and discussions. If you all have questions about enterprise AI strategy, infrastructure design, deployment models, operational management, or governance framework, please feel free to ask those questions. I'll be happy to discuss any of those particular areas.
Thank you, Akash. That was very informative. Now, I know everyone is looking forward to the Q&A session, so go ahead and start putting in your questions into the question panel. And while you're doing that, I'd like to give the presentation rights over to 𝗕tica Singh, our Deputy Manager Product Marketing, who's going to introduce our promotions and webinar-related courses.
Thank you for extending the opportunity to speak with the audience today. I hope the session was informative and it added value to your learning experience. You can watch the event recording by clicking the Access Recording button here. Now, I would like to highlight Netcom learning capabilities and why we are the best when it comes to training and learning services. Recognized by Microsoft as the winners of the Partner of the Year awards 2 years in a row, 2023 and 2022, we excel in guiding organizations to achieve peak performance while addressing their challenges through comprehensive organizational learning solutions. Our dedication since 1998 has led us to service over 80% of Fortune 1000 companies and served 100 plus US military bases. We have trained over 1 million professionals and helped 36,000 plus organizations achieve their business goals. We have a huge portfolio of more than 3,300 certified trainers who are subject matter experts in their domains. Our dedication to providing customized learning methods is why we are awarded as the top 20 IT training companies by trainingindustry.com. Moving ahead, being a platinum learning partner of Cisco, I would like to announce our upcoming schedules of Cisco training that you can explore through this handout. To add value to your learning curve, we encourage you to leverage free on-demand training and blog on Cisco certifications. If you would like to maximize your Cisco ROI with unlimited access to in-depth training and hands-on labs, then enroll in our Cisco U Essentials and Cisco U All Access subscriptions. Cisco U is a digital learning experience that recommends personalized content for each learner spanning through Cisco and Cisco adjacent technologies, including unlimited access to hands-on labs. Cisco U is more than just a digital learning subscription. It's a thriving community of learners and creators for learning and growing. As a Cisco Platinum Learning Partner, Netcom Learning helps organizations purchase authorized Cisco training with Cisco Learning credits to increase the technical competencies of their employees and deliver greater technology returns. Cisco Learning Credits or CLCs are prepaid training vouchers redeemed directly with Cisco that help you purchase, redeem, and manage Cisco training courses. You can use your CLCs to upgrade your team's expertise with our authorized Cisco training available for public and private training schedules. You can also take the advantage from Learning Passport, which is Netcom Learning solution, to flexible team training. It is designed to be customized for the number of learners you train on top technology vendors like Microsoft, Cisco, CompTIA, Adobe, and more. The single package can be redeemed for over 4,000 plus official courses with a validity of 12 months. I would recommend you all to visit Netcom Learning's website for more information on our courses and certifications, free virtual events, our latest blogs and ebooks, and promotion offers. If you want to build a smarter workforce and drive business growth, I highly recommend you go through the book Building an Innovative Learning Organization by Russell Sarder, CEO of Netcom Learning. You can easily find this book on Amazon. For the latest updates on IT and business training, follow us and subscribe to our social media handles. Thank you for joining us. Have a great day.
Thanks so much for guiding us through that valuable information, 𝗕cia. And now we're going to go ahead and jump right into our question and answer session. If you haven't yet, it's not too late to pop your questions into the question panel. First question is, you mentioned that organizations should assess readiness across dimensions like data, infrastructure, talent, governance, and strategy. For organizations that score low in the talent or skills dimension, what practical steps should they take to start building those capabilities?
Okay, that's a great question. And in fact, this is one of the most common gaps that organizations discover whenever they begin evaluating their AI readiness. Most organizations, they score reasonably well in the areas like infrastructure or strategy. But when it comes to talent and skills, they often realize that their teams are not yet fully equipped to design, deploy, or even manage the enterprise AI systems. So the most effective way in how we can address this is usually through a structured and phased upskilling approach. The very first step is to build your foundational AI awareness, and that has to be done across the organization. See, not everyone needs to become a machine learning engineer, but teams across IT, infrastructure, security, and even leadership, they should understand how system of the AI work, how AI models are trained and deployed. So this will be the foundational understanding that will help everyone to align different team members across a common AI vision. And once that is done, then comes the second step. Second step is the role-based specialization training. See, we have different professionals, so definitely they require different learning path. For example, in the organizations, if we are talking about engineers and the developers, right? So they may focus on machine learning framework. They should understand the model deployment, model development, and the MLOps pipelines. Now, if I talk about the infra and networking teams, right? So infra and networking teams, they often focus on AI infrastructure architecture, GPU environments, and distributed systems that support large scale training workloads. And finally, we talk about the security and the governance team. So they should typically focus on AI risk management and compliance frameworks for responsible AI practices. Then comes the third step. Third step would be the hands-on implementation. So this is where your teams will move beyond theory and will start working with the real environments. So in practice, what many organizations end up doing is creating a structured capability building roadmap, which will include your foundational knowledge, specialized learning path, and practical experience so teams can gradually develop those capabilities internally. And this is also where organizations sometimes partner with the training providers. For example, we at Netcom Learning, we try to support structured upskilling initiatives and structured led programs that will help teams to create these skills which are required to design, deploy, and even operate AI environments for more effectively. Let's move on to the next question, please.
Second question. In your experience, when organizations start their first enterprise AI initiative, which deployment model do they typically choose? Cloud, private AI, or hybrid? And what factors usually drive that decision?
Understood. Yeah. See, this is one thing which we have already discussed, right? And it's a very practical question. Most of the cases, as far as my experience goes, organizations typically start their first initiative into the cloud only. The main reason I'll tell you is the speed and accessibility. Cloud platforms, they already provide you everything which is ready to use AI service, whether it be GPUs, infrastructure, or any managed machine learning environment. So this allows your team to experiment quickly, even without investing to the hardware part heavily. But as organizations move from experimentation to production, many begin shifting towards the hybrid architectures. So the final decision usually depends on several key factors. It depends on data sensitivity and regulatory requirements. Um, you should look for your existing infrastructure investments, your scalability and compute requirements, and even the cost and operational flexibility. So typically the journey looks like cloud will be for experimentation, hybrid will be for scaling, and private environments will be there for highly regulated workloads. Let's move to the next question.
Next question is, you highlighted that networking and compute can become bottlenecks for AI workloads, especially during model training. For enterprises that already have traditional data center infrastructure, what are the key upgrades they usually need before running large-scale AI workloads?
Okay, that's a great question. See, most of the traditional data centers, they are only designed for CPU based applications. But as I told in this session also, AI workloads, like especially the training one, they require much more compute power and data movement. So typically organizations, they make three key upgrades. First, they add GPU based compute so that they can handle large model or large scale model training. Second, they try to improve their storage performance. Yes, so that they can support high throughput data access. And lastly, they try to upgrade their network's bandwidth and latency, because often moving to faster data center fabrics. Why? Because GPUs can exchange data efficiently. So in simpler terms, the biggest changes usually happen in compute, storage, and networking. Next question, please.
Next question is, many organizations run AI pilots but struggle to move them into production. From your experience, what are the most common reasons pilots fail to scale, and how can teams avoid that?
See, that's something we quite often see in the environments. Because see, what happens is many organizations, they successfully create AI pilots. But once the time comes to scale them into production, it becomes very difficult due to some of the very common reasons. I can highlight those reasons. Um, First would be your data readiness. Because see, whatever data you are using in the pilots, that is often cleaned and controlled. But you should agree that the real production data, it can be very messy and inconsistent. So data readiness is the first reason. Second reason, in my perspective, would be your infrastructure limitations. See, pilots, they may run on small environments, but once you are scaling, right, it must require proper compute, storage, and even the networking capacity. So, in my perspective, infrastructure limitation should be the second point. And third, third would be the lack of operational processes, such as monitoring models, managing retraining, or even establishing the governance. So the way teams can avoid this is by thinking about production requirement early. Not only just building a model, but you have to plan the entire life cycle. You have to think for data pipelines, infrastructure, monitoring, and even governance from the very start. And that is only how you can overcome these challenges. Next question, please.
Fifth question in the queue is, you showed several roles required in enterprise AI environments like AI ML engineers, data engineers, and governance leads. For professionals coming from networking, infrastructure, or cybersecurity backgrounds, what learning path would you recommend to transition into enterprise AI roles?
Okay, that's a really interesting question, especially for professionals who are coming from networking, infrastructure, or cybersecurity backgrounds. And the good news is that many of the skills from those domains are actually very relevant in the enterprise AI environments. And a good transition path, it usually starts with understanding the fundamentals of AI and machine learning. Not necessarily to become a data scientist, but to understand how models are trained, deployed, and used in the real systems. So the next step would be to focus on AI infrastructure and operations, because AI workloads, they rely heavily on the distributed systems, GPU infrastructure, cloud platforms, and cloud orchestration. So these are the things which are already familiar concepts for many of the infrastructure professionals. And finally, professionals, they can specialize in areas like AI security. You can specialize into MLOps or even the AI platform architectures. So this is something where the professional's background in networking or security becomes even extremely valuable. So the key idea is just to combine the existing knowledge or your existing infrastructure expertise with the AI fundamentals. And this will open up many roles in the enterprise AI environments. Let's take one more question, please.
And finally, before we wrap it up, we have one last question. If someone wants to go deeper into topics like enterprise AI architecture, AI operations, or governance frameworks, are there any structured training programs or courses that are available that cover these areas in more depth?
Yes, for professionals or organizations that want to go deeper into the enterprise AI or AI operations, or let's say governance framework, as you asked, there are definitely structured training programs available. And those particular programs, they typically cover all the topics like AI infrastructure design, model lifecycle management, MLOps practices, AI security, and this governance framework. So these are very essential for running your AI system successfully in production environments. So here also at Netcom Learning, we do offer the instructor-led training programs and even the certification pathways, which are focused on these emerging technologies, which include the AI and enterprise AI adoption. All of these programs, they're definitely designed to help anyone understand not only the theory, but also the practical aspects of how you can deploy and manage these AI solutions in the real enterprise environments. So for anyone who is looking to create a deeper expertise or structured training programs, all of these programs like these, they can definitely help the professionals to develop those skills, which are definitely needed to redesign, deploy, and even operate enterprise AI systems effectively. So great questions, everyone. and I really appreciate this engagement. Now, let's go ahead and move towards the wrapping up of today's session. So, thank you so much, everyone, for joining today. I hope this masterclass provided useful insights into how organizations can move from AI strategy to real enterprise scale deployment and operations. It has been a pleasure sharing these insights with all of you today. And I hope the concepts that we discussed help you to continue as in order to build and scale the AI capabilities with the organizations. So thank you again for your time and participation. Have a wonderful day ahead.
Once again, I want to remind you that as you leave this session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.